So we're going to go back to our original formula. PV is equal to nRT.
Okay.
And so when I'm talking about Charles' law, I'm going to look at the relationship between those two variables. So everything else is going to stay the same. The pressure is going to stay the same, the amount of gas is going to stay the same, and the ideal constant is going to stay the same.
Okay, got it.
Okay?
Yeah.
So I want to put these two things on the same side of the equal sign, so how do I move that t?
It's divided.
It's divided. So this is where your relationship comes from, because V1 over T1 is equal to V2 over T2. And this is Charles' law. So if that's the case, if I'm looking at this thing, if I were to increase the volume, what would I have to do to the temperature in order to keep all of these numbers the same?
You would have to increasing the volume.
Mm-hmm. How are they related to one another?
You have to increase the temperature.
Right. So what kind of relationship is that?
It's a non-positive relationship.
It's a direct relationship.
Okay.
That's a direct relationship. As your volume goes up, your temperature actually has to go up too, so this number stays exactly the same.
So this is what happens when you heat something up.
Right. You increase the temperature, so the volume has to increase. You decrease the temperature, so the volume has to decrease.
Okay.
So when you take and the reason that happens is that the kinetic energy of the gas molecules is bigger. So in order to actually keep your pressure the same, you have to increase the volume, so the distance that they cover is going to be a bigger distance.
Okay.
Right? Because the faster something moves, the quicker it'll get to one side or the other, right?
Yeah.
So the only way that I can keep the pressure the same, which is the collision of the gas molecules on the side of the container, I have to increase the size of the container, so the average amount of collisions will still remain the same.
Okay. All right.
Okay? So remember, these two things are directly related to one another. Okay?
Yeah.
Now I'm going to write my ideal gas law again. Is equal to nRT. And I'm going to hold these two. I'm going to hold everything constant except for those two variables.
Okay.
So how are P and T related to one another? If V and T are directly related to one another, how would P and T be related to one another?
Indirectly. When temperature.
This is what you need to remember. When two variables are separated by an equal sign, it's always a direct relationship.
Okay.
When two variables are on the same side of the equal sign, it's always an inverse.
All right.
Because look, in order to move this T on the same side as the P, right, this T, I want to move it on the same side as the P. How do I move this T over to this side of the equal sign? Divide. So you get, doesn't that relationship look just like the one above it?
Yeah.
Oh, sorry.
I thought your X was just.
That's 1. So you're trying to make it more complicated than it is. It's the same exact relationship except for it's two different variables.
Okay.
So this is also a direct relationship. And this is Gay-Lussac. I think it's AAS. I can't remember. Sorry. It's LUSSAC. When you take all three gas laws and the only thing that you hold constant is the amount of gas, then you get the combination law. which says that P1V1 over T1 is equal to P2V2 over T2. So they'll give you 5 of those numbers, and you'll have to solve for the 6th.
Okay.
And that's called combined gas law. So you have the ideal gas law, you have combined gas law, and then you have the other 3. So you have 5 laws altogether for the gas laws.
Okay.
And depending on what you hold constant is going to determine which law you use.
Okay.
So let's do some questions from your worksheet. The important thing with these worksheet questions is to just basically identify what they're giving you. So let me try to scroll down. And then we just did ideal gas law. Okay, so you see the different R constants there, right? If it's kilopascals, it's that number.
Okay.
If it's atmospheres, it's that number.
Okay.
I don't remember what the number is for torr, but
I don't remember learning about torr. I think we're just doing those 3 for now.
So let's see if we can find some questions to do. Okay, so this one's Boyle's law.
Will they give you different laws? Like, they'll tell you, like, Boyle's law, Charles' law, or
no, not always. They'll just give you some stuff, and then you'll have to figure out which one to use.
So you just look at
So
what
you look
they're
at what
asking
you look at what's held constant, and it's going to tell you which law to use.
So
Copy, and let's see if I can paste this into the other thing. So
look at that. How fancy.
okay, so I know that's really small,
I
but
can read it.
we'll just deal with it. Okay, so a bike pump holds 75 liters of gas. 0.75 liters of gas. So
You just made it smaller. Try using the big dot and see if it makes it bigger. Dang.
That's too big. Okay.
Because it's still in text. Yeah.
Oh, it won't do 2 things at the same time? Really?
That's just cheap.
Yeah, that sucks.
That's not even fun. Who do they think they are?
Okay. So if I hit, it still goes away. That stinks. That's what free gets you.
Oh, is it free?
This like website is free. I wonder what else I can do to get off of that. Anyway.
You can paste it into the URL bar.
Can I get out of this text box?
Maybe you just did it.
I think I just got out of the text box. Yes.
Yeah,
okay.
there you go.
All right. So all of that, and this is about to